Hi everybody, welcome to part 5 in what's an ever-growing series on this receiver. So this is the power supply down here that partially feeds the solid state portion of the tuner, and as you can see I ended up recapping it. These capacitors were unbelievably bad. They may not look it, but they were really bad. They have really high ESR. I mean, I'm talking, 70, 80 ohms. And some of them were reading 3 to 4 times the capacitance that they're rated at. All the telltale signs that they're bad. So I just, for the 5 capacitors that was on the board, I just recapped it very quickly. And all is good. Now we're kind of focusing on the rest of this. We're going to actually look at, if I can get the camera to move, we're going to look at the front end here. And as you can see, I have removed all the evacuated thermonic transconductance devices, all 3 of them. And I've loosened this little set screw, and I clamped the dial string on either side here to keep it from moving. And I've loosened this set screw, and I've put some tape around here, so this should allow this to kind of stay in place while we remove it, because we're going to have to pull this module out to see. You could see how it's like sticking up here. Somebody had it out, and we need to fix that before we do anything else. So we're going to do that right now, and this is just as simple as very carefully removing it, as long as we can get this loose enough. Yeah, it's loose. And we now have this thing flipped over and very precariously taken apart. And one of the things we have to be cautious of is we cannot move any of these coils here. By bending the coils and changing the distance on them, we will actually change the inductance, which can throw the thing out of tune. So we don't want to mess with that. I had to remove this lead of this capacitor to get it out from under there, and then I just kind of untucked it from underneath there. And now we can put this up here the correct way, and it fits properly. So I'm going to put that back on before I do anything else, and then we'll start cleaning some of this up. We're back together and just did a quick spot check of the resistors. They all are in tolerance. Everything looks to be good, and it doesn't look like there's been much, if any, work done here at all. So good possibility that that was pinched under there from the factory. We don't know, but I'm starting to think that. So that's good news. So I'm going to put this cover back on, and we're going to start doing some initial testing on the front end of this tuner. Another thing I noticed as I was putting this cover back on is, remember I told you that you want to make sure you don't bend these coils. Well, sure enough, you can see this is RF and this is oscillator. These are actually your alignments for the oscillator and the RF front end of this module. Okay, let's set up the scenario here. We have our trusty old 8657 set up for FM modulation. We're set to 94 megahertz. I'll tell you why that in a minute. And we're looking at about 30 microvolts of drive signal, which is a pretty decent signal going into the input. The good news is, I can't believe it, if you look at the dial, we are right on just about 94 megahertz. So there's 92, 94, 96. There it is. And if you look at this, this is an older tuner from Japan. And if you notice, instead of going from 88 to 108 megahertz, it goes from just below 80 megahertz, like about 75 megahertz, up to 108. So 94 is pretty much the center of travel of this, and that's why I chose that. Normally you would use 98 megahertz because it goes from 88 to 108, and 98 would be the center. But since this has a wider bandwidth, that's why I chose that. So you can see the meter is working, and it tunes in right on 94. But here's the badness. First of all, it's very deaf. There's not very much sensitivity in this receiver. And if you look at the two channels, they do not match. We're looking at the record outputs. You know how we normally do that when we set up one of these receivers. We set up the FM and the receiver portion. You can see there's a major imbalance between right and left channel. The waveform is distorted in shape. You're seeing a lot of static, a lot of interference, even though we have a 30 millivolt or a 30 microvolt. And you can see I can go, before it gets clean, I have 944 microvolts before the static starts going away. That's way too much. So this is the best I can get where you can see everything at once. And I've already touched this up, and it almost was spot on the whole way across the board. As you can tell, I was able to get that waveform to be a lot more symmetrical and proper for a sine wave, although the amplitude between left and right channel are still not correct. The IF and RF sections were almost perfect. There was just a couple of these little coils. So you have these two coils here that will adjust, and I'll show you what they do. Then you have your first mixer coil here. This is kind of at the end of the mixer stage. Then it comes out of here and it goes through a whole chain of IF sections, and there's top and bottoms to each one of these cans, these IF cans, these transformers, and they were almost all perfect. This one here, the top slug was a little bit off, and as soon as I adjusted it, it straightened that right out. And I was able to get just a slight amount more gain out of the whole thing, but really it was very close. I was very surprised. So let me show you what I meant by moving these coils. I'm just going to flex one a little bit. This is the oscillator coil, and watch what happens to the waveform when I move this coil with this stick. See what's happening? See how it shrinks? See that? And it distorts. So the idea is you move these little coils apart for maximum amplitude. And same thing with the RF side. If you just move that coil a little bit, and I don't want to move it too much because I don't want to make it, you can see how it kind of crushes down. And if you move it the opposite direction, and this is how you know you have it, if you move it apart more, it goes down. So really, these coils are properly adjusted. You don't want to touch them. Now that I know everything works, and now that I know all of these coils are pretty much peaked, before we even worry about multiplex and stereo and all that, I want to get a good solid audio signal coming out of this thing before we can even worry about pilot detection and multiplex and so forth. So, long story short, I'm going to do a recap on this tuner for that very reason. I found some really bad capacitors in the power supplies, and I have no reason to think that the rest of these aren't just as bad because they're all the same age. So that's what I'm going to do, and once I do that, we'll come back and we'll see if this improves any from what it looks like right now. Just to give you an idea of what we're up against, here's 3 capacitors that we've replaced so far. They're all 10 microfarads at 12 volts. So here's our first one. And if we look, (28 microfarads), so it's more than double, 20 ohm ESR. (23) with a 20 ohm ESR. (49 microfarads at 17 ohms. Every one of them's reading like that. And just for the heck of it, we'll look at one of these. And this is a brand new one. This one's 10 at 50. I'm replacing it with 10 at 15, but this one will give you an idea. 10 microfarads. ESR is down to 2 ohms instead of 20. Right on. And that's what it should read like. So every one of these caps is bad. So another update. As you can see, we have everything recapped here. And I replaced this transistor right here because the one that was in there was kind of noisy. This one was still good, but somebody had just tacked it in, so I removed it, cut the leads to the proper length, and reinstalled it. It's fine. So now what we have to do is we kind of have to go through all this and break it down into how it works and try to come up with some sort of plan. What I'm finding is just the tuning portion by itself is fine. In other words, it can receive stations. It's fairly sensitive, but the multiplex circuit is not working at all. And this is not a normal, like what we're used to seeing, 1970s era multiplex. It is a very early type of multiplex circuit. And we really need to go to our schematics to kind of look at how this whole receiver is put together. So let's do that. Okay, after a brief Tony getting busy at work delay, we are back on the bench. And I want to kind of catch you up to where I am with this. If you remember where we left off, we were always able to receive FM stations, but they were only in mono and we couldn't get stereo to come up. It just didn't work at all. And we went through and kind of peaked up all the RF and IF section, and we're now into the multiplex, which I have rebuilt, and I'll show you that. So I've completely rebuilt the multiplex board, replaced all the capacitors. I did find that this transistor right here was noisy. It just had a lot of static and noise. So I replaced these three with Russian Russian replacements, and they're Russian germanium, and they're actually really turning out to be very good quality transistors. It's really nice. I was surprised how well they worked. So what I want to do now is kind of show you how this works and kind of where I am in the troubleshooting process. If you look up here, we have our front end. So you have RF coming into this module, this is the part that has the vacuum tubes on it. Comes out of there and it goes into that 5-stage intermediate frequency, or IF board. So all this is doing, as I said earlier, is gradually increasing the gain of your IF all the way out to here, till finally we get into a little, I think this is a Foster-Seeley. Am I saying that right? I don't know. I don't know anything right now, but it's the discriminator circuit. So this is your FM detection. Once it detects, removes the intermediate frequency, the 10.7 megahertz, what you have coming out of here and going through this little level control pot, and all this is a level control, and it was bad. It was reading about double the resistance it should. So I replaced it with a new potentiometer. It's supposed to be, what's it say, a 50K pot, and it was reading like 96K. So I put a new 50K pot. This is really important, and we'll get into that, why it's so important here in a minute. All this is an attenuator for the output. So what's coming out of here is your audio. There is no longer any RF. It's all audio range, including, if it's a multiplex signal, including your multiplex signal. So it comes through here, and it feeds into what I'm finding is a very interesting little circuit. And I'm going to show you a few things on the oscilloscope that's very interesting. So we come in here, let's say that this is just a mono FM signal. all that's going to happen is the audio is going to come in here. It's going to go through this decoupling cap. It's going to go into this first transistor, and at the emitter, it's going to come out and go through here, through these filters, and we'll get into those in a minute, up into the output of this coil right here, of this transformer. And then it just gets split into two outputs, and it's just two equal mono right and left signals. So it's not right or left, it's just two channels of mono, the same signal, which feeds into your output amplifier, which goes out to your record jacks or to your preamp section of the amplifier. This part is very fascinating though. If you just have the straight mono signal, this coil right here acts pretty much just like a resistor, and it's a very low resistance resistor. It's only a few ohms, it's not a whole lot. And this essentially takes this collector to ground. So what's going to happen is this emitter, it's just going to be like an emitter follower. And all these other things are just going to get bypassed here. However, if we put a multiplex signal, that multiplex is going to have a 19 kilohertz pilot signal. This and this are both tuned to resonate at 19 kilohertz. All of a sudden, the collector side comes to life with that 19 kilohertz, and now your modulated signal with your 19 kilohertz is going to go through here, going to get amplified, go through here and oscillate more, go through here, and eventually we're going to double our frequency up to our 38 kilohertz, which is going to feed into this transformer, which is going to get detected here, which is going to become your right and left signal. Down here, you also have these couple of coils and capacitors that act as traps. So one of them is going to be these are for your SCA or your secondary carrier. One of them is going to be for your 67 kilohertz trap. I'm sorry, right here. And then the other one is going to be your 72 kilohertz trap. 67 and 72 are the edges of your SCA bands, okay? So 72 is going to be the first harmonic of your 38 kilohertz, which is what we need for our stereo. So we want to trap that out. And the 67 kilohertz is going to be for your SCA frequency, which we want to trap that out. So it's really cool how this works. So the first place we're going to look at right now is this red wire, this red coax. This board over here is your IF section, and this is your detected audio. So this is the audio that's coming out of the IF board going into the first part of the multiplex board. And I soldered just a little wire so that we can clip onto here and we can actually look at the signal there and with respect to ground. Okay, so let me move you up to my oscilloscope, the other oscilloscope, and we're going to look at this signal. And you can see right there, you are looking at the sine wave, and it's actually the 400 hertz audio tone that's being modulated. So, and you have a really nice clean looking audio going in there, and I can shrink that, make it a little more visible here if we want, so you can see. And yes, I really need to clean these controls on this thing. So you can see, there it is. Now, that's your mono signal. If I go to stereo, don't worry about that ghosting there, it's kind of right there. You can see that there's your 400 hertz, and then that zigzaggy line there is your 19 kilohertz pilot tone riding on it. Okay, so just remember that. Remember those two signals. So we're going to go back to mono and to stereo. There's mono. All right, so I'll come over here we're going to go back down to this area. And we're now going to remove the probe off the scope, or off of this test point here. And we are going to actually look in our multiplex. I'm going to show you, first we're going to look at this emitter with stereo and mono. Then we're going to look at the collector of Q1 in stereo and mono. Okay, so take a look at that. So first we're going to go here, then we're going to go here. So let me get set up. Okay, we're now on the emitter, and if it bounces around, it's because I'm holding the probe on the circuit board. And if I go to stereo and mono, you can see once again that we get the same signal on that emitter, right? Now if I move to the collector of that transistor, I am now in mono mode, and watch what happens when I go to stereo. Now I have to move my time base, and let's see if I can, and you can see right here, there's your 19 kilohertz with the audio riding on it. See how it's that fuzziness? That's your 19 kilohertz with your audio. Now the amplitude is much lower, right? So if I go back up here, it's much higher, and that's your 400 hertz. If I go down back to the collector, there you go. If I go again to mono, you can see it just goes away. So that first stage is working. In other words, that coil that we were looking at, which is right here, is resonant at 19 kilohertz. When we were down here, we were seeing both the audio and the pilot tone, both, it didn't care. So what that means is when this one with our 19 kilohertz pilot, we should have that signal come through here and be amplified, and then it should be at the collector of this one. So let's look at that. Okay, the collector of the second transistor, which is also the coil, and you can see it's the same signal, just amplified. Okay, so here's our first collector of the first transistor, and the second collector, which is the second transistor. So far so good, right? So far we have audio, and it's going the way it should. Now here's where we're going to have a problem. When we come out of here, we already found that at the collector of this transistor, we have an amplified 19 kilohertz. And if you look here, the way this works, this is actually going to, these two steering diodes on either side of this coil, what they're going to do is they are going to double the frequency. So in other words, you're going to have like two pulses. So what you're going to have is a 38 kilohertz signal going into this transistor here, and that 38 kilohertz will be amplified by this transistor. It will go into this split coil transformer here. It will be tuned to 38 kilohertz, and then because of that, you'll have your left plus, left plus right, left minus right, and so forth, which is going to go against your multiplex signal and is going to give you your left and right channels, which will be detected by this little circuit right here. We are not getting 38 kilohertz. That's our problem, and that's what I'm having a really difficult time figuring out right now. I'm not getting 38 kilohertz right here. So I don't know. I've checked these diodes, I've checked the capacitor, I've checked, a lot of different things here, and no matter what I do, I cannot get 38 kilohertz at that test point. And that test point's going to be right at that 5.6K. which is right up here. I'm standing way back. see if I can, there we go. Right there. And you can see all I get is that wonky looking signal there, and it's very, very weak. I'm at 20 millivolts per division, and if I sync it up just right, you can see that little signal we're getting, and that is certainly not 38 kilohertz. That's actually closer to our 19 kilohertz, but it's not, you can see it's not oscillating properly. Well, we've made a little bit of progress. Couple of things. First thing was I checked down here at these diodes, and I tested the ones that were in there. They tested good, but I don't know, I just wasn't able to get what I needed through there. So I replaced those two diodes with a pair of Schottky diodes, although I'm not 100% sure they needed replaced, but once I had them out, I figured I would just put the new ones in. The other thing I noticed was I needed a stronger drive signal than I thought coming out of here. Remember, I do not have any documentation how to calibrate this circuit, and it is quite different from the all solid state version of this. The boards are different, everything. So what I did was, by getting enough drive signal to the 19 kilohertz, we're now getting, if you look, that signal out into this transformer. Now, let's take a look at that signal for a minute. And yes, it doesn't look pretty, but we don't care. This is just about timing. It really doesn't matter about its shape. The idea is you want the period to be correct on it. So let's count where we are if we go from one peak to the next. So if we're at 5 microseconds per division, we go 5, 10, 15, 20, 25, and about roughly 26 microseconds, okay? So those pulses are 26 microseconds apart. And if frequency is 1 divided by time, if we take 1 divided by 0.000026, you can see we get 38 kilohertz. How about that, huh? Isn't that cool when the math works out? So we have our 38 kilohertz going into this transformer now. And another thing I noticed that happened was that I've never had happen before. We have a stereo beacon. Now, I did have to rebuild this stereo board up here. This is the whole purpose of this board, for the most part, is just to sense the multiplex carrier and the pilot signal and to turn that light bulb on. It really doesn't do much else for the rest of the circuit. And it did have one bad transistor, one poorly installed transistor it need reinstalled. I replaced one capacitor, and several of these resistors, this one here, this 4.7K, the 33K, and the 3.3K, those ones were way out of tolerance, so I replaced them. This SV2 diode was bad. It would read, but it would, if you just put your meter on it and let it sit there, you could see it jitter around. So I replaced that with a UF1004, and now that circuit is working. I really haven't done a whole lot to the tuning of it, but it seems to be working. So, well, we now have somewhat of stereo, but we are still not decoding the stereo. So when it comes out of this transformer, we should be able to adjust these two potentiometers and adjust this coil, and eventually we should be able to get separation between the two channels, because what's going to happen is you have you have your signal down here, and this is just the straight mono signal will come through here along with the 19 kilohertz. It'll go through this, it'll make it through the 67 kilohertz trap, and you can see it's at the output of this transformer. Then over here, as I showed in the earlier clip, these two coils will oscillate at 19 kilohertz, at which point we'll get a 19 kilohertz signal here. And since this is a split transformer with the secondary ground, or the center tap of the secondary grounded, what you're going to have is a full wave rectified, and no, it's not a full wave bridge because it's two diodes, but a full wave rectified signal. So you're going to have, instead of having a sine wave that is 19 kilohertz, you're going to have a pulse wave, just a DC pulse wave at 38 kilohertz. And that's what you were just seeing on the scope, what I showed you. That 38 kilohertz will mix in this transformer with the original multiplexed signal and the 19 kilohertz, and that's what's going to give you your left plus right, left minus right, and eventually become your left and right signals. Those are detected by this little circuit here, and then it goes through this little filter circuit and into your amplifier. And this now is where we're losing it. We're not getting separation. So I can adjust this now, and it will affect that 38 kilohertz. It'll actually drop out of oscillation if I turn this now. I have it set. So now, why are we not getting separation in here? That's the next question. And I'll tell you, at this point, I'm stumped on this one. I'm going to really have to think about this. So what I'm going to do, because it's been so long since I've posted a video, I'm going to end this video. I'm sure it's getting pretty long. And so I'm just going to edit this video. I have a whole bunch of clips I need to edit out here and kind of make sense of what you're seeing. And we'll get this one posted. And hey, any of you tuner folks out there that really know FM multiplex circuits, and especially these old analog ones, I just explained where we are. If you have any ideas or suggestions, put them down in the comments section. I'll be more than happy to hear what you all have to say. In the meantime, after I get this edited and posted up there, I'm going to go back to work here and see if I can figure it out. So, as always, I wish you all peace, joy, happiness, and good health in your lives. I hope all's going well with all of you. And this has been quite a journey in this thing, hasn't it? But little by little, we're figuring it out. So, again, any comments, any suggestions on what we could do to fix this, let me know. And we'll be back soon with another video. Take care, everybody. Bye-bye.